Jai Hind, myself Dr. Alok Vardhan. Currently, I am working as an assistant professor in the Department of Mechanical Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today, I will discuss one of the important topic of the subject fluid mechanics and fluid machines. And in this lecture, I will discuss about what is fluid mechanics, their classifications, then what is fluid properties, what is pressure, what is Newton's law of viscosity, then what is Newtonian and non-Newtonian fluid, then what is Pascal's law, and in last I will discuss what is continuity equation. So, what is fluid mechanics? So, basically it is the branch of science which deals with the behavior of the fluid, either it may be liquid or gaseous, either at rest or in motion. So, basically the study of fluid mechanics is divided into three parts. First one is fluid statics, then fluid kinematics, then fluid dynamics. What is fluid statics? The study of fluid at rest is called fluid statics. Then the study of fluid in motion, where pressure forces are not considered or comes under fluid kinematics, and the study of fluid in motion, where pressure forces are also considered, which comes under fluid dynamics. So, these are major classification of fluid mechanics. Then, what is fluid? Basically, a fluid is a substance which is capable of flowing or deforming or moving under the action of shear force. When there is no shear force, the fluid will be at rest. Further, fluid means either it may be liquids or gases. In liquids like water, oil, mercury, etc. In gases like air and water. So, this is fluid. Then, what is now I will discuss in further and subsequent slides, I will discuss fluid properties. So, the first property is density or mass density. It is denoted by symbol rho. What is density or mass density? It is the ratio of mass of the fluid to its volume. And density is defined as mass of the fluid divided by its volume V. Its unit is kg per meter cube, and density of water is 1000 kg per meter cube at temperature 4 degree Celsius. Okay. So, this is the all about regarding density. Density depends upon temperature and pressure. With rise in temperature, density decreases, whereas with rise in pressure, density increases. Okay. Then the second property is specific volume, and it is denoted by symbol small v. What is specific volume? It is defined as the volume of a fluid occupied by a unit mass. The volume per unit mass of a liquid is called specific volume. The specific volume small v is equal to capital V by small m, and its unit is meter cube per kg. We can also write small v is equal to 1 upon m by v, and we know that m by v is rho. So, basically specific volume is the reciprocal of mass density. Then the third property is specific weight or weight density, small w. What is specific weight? Basically, it is the ratio of weight of the fluid to its volume. Means specific weight is equal to weight of the fluid to its volume. We know that weight is the product of m into g divided by v. So, basically we can write specific weight is m by v multiplied by g, and we know that m by v is rho into g, means we can say that specific weight is also the product of density of the fluid multiplied by acceleration due to gravity, and its unit is Newton per meter. Then next property is specific gravity or relative density, denoted by symbol capital S. What is? It is the ratio of density of the fluid to the density of standard fluid. So for liquid, the standard fluid is water, whereas for gases, the standard fluid is air. So for water, the density of water is taken as 1000 kg per meter cube, whereas for air, the density of air is taken as 1.21 kg per meter cube. So what is specific gravity? Specific gravity is the ratio of density of any fluid with respect to density of standard fluid. So for liquid, we can take water as a standard fluid, whereas for air, we will take air. For gases, we will take air as a standard fluid. And specific gravity is can also be written as density of fluid multiplied by G into density of fluid and density of standard fluid multiplied by G. We know that density of fluid multiplied by G is specific weight of fluid divided by specific weight of standard fluid. By using these two formula, यानी कि specific gravity or relative density is the ratio of density of the fluid upon density of the standard fluid, या specific weight of the fluid upon specific weight of the standard fluid. So by these two formula, we can calculate the specific gravity or relative density of any fluids. Then I will discuss what is viscosity या dynamic viscosity. So basically, viscosity is the internal resistance offered by one layer of fluid to the other layer. So basically, it is the internal friction offered by one fluid layer to the other. Its unit is kg per meter second, या Newton second per meter square, या Pascal second, या poise. So basically, we can say 1 kg per meter second is equal to 1 Newton second per meter square, या 1 Pascal second, and 1 poise is equal to 0.1 Pascal second. So basically, poise is the CGS unit of dynamic viscosity, या viscosity, and its SI unit is Pascal second या Newton second per meter square, and 1 Pascal second is equal to 10 poise, या 1 poise is equal to 0.1 Pascal second. Now I will discuss what is the effect of temperature on viscosity या dynamic viscosity. So in this figure, we can say that this is temperature axis and this is viscosity axis. So with rise in temperature, viscosity of gases is increases, whereas viscosity of liquid decreases. So we can say with rise in temperature, viscosity of gases increases, whereas viscosity of liquid decreases. This is the effect of temperature on dynamic viscosity or viscosity. Then another property is kinematic viscosity. What is kinematic viscosity? It is defined as the ratio of dynamic viscosity to the density of fluid. And we can say it is denoted by symbol nu. So nu is equal to, यानी कि kinematic viscosity is the ratio of dynamic viscosity mu divided by density, and its unit is meter square second, meter square per second, and its CGS unit is Stokes, and 1 Stokes is equal to 10 to the power minus 4 meter square per second, या 1 meter square per second is equal to 10 to the power 4 Stokes. So this is kinematic viscosity. Then another property is pressure. What is pressure? So basically, pressure is the existence of mass in nature is directly meaning existence of pressure. Mathematically, it is defined as external thrust per unit area, यानी कि P is equal to external thrust F by A is called pressure, and its unit is Newton per meter square, which is also known as Pascal. So this is the SI unit of this pressure. Another unit is kilogram force per centimeter square bar PSI atmospheric pressure, and we know that 1 Newton per meter square is equal to 1 Pascal, 1 bar is equal to 10 to the power 5 Pascal, या 10 to the power 5 Newton per meter square, and 1 atmospheric pressure is equal to 101,325 Pascal, or nearly we can say 1 bar. So this is all about pressure. Pressure is a scalar quantity, but pressure force is a vector quantity, and its pressure force acts always perpendicular to the plane. Okay. Now I will discuss different types of pressure. So the first one is atmospheric pressure, then absolute pressure, gauge pressure, and vacuum pressure. There are 4 types of pressure: atmospheric, absolute, gauge, and vacuum. So one by one, I will discuss what is atmospheric, what is absolute. Basically, atmospheric pressure is the pressure exerted by the environment mass is known as atmospheric pressure. Then what is absolute pressure? It is the total pressure of any system measured from zero pressure line is called absolute pressure. Then what is gauge pressure? It is the pressure of any system above the atmospheric pressure value is called gauge pressure. Then what is vacuum pressure? It is the pressure of the system below the atmospheric pressure line is called vacuum pressure. In this figure, this is zero pressure line. Here pressure is equal to 0 atmospheric. This is atmospheric pressure line, and here pressure is P atmospheric is equal to nearly 1 bar, या 101,325 pascals. The pressure above this line is called gauge pressure, and pressure below this line is called vacuum pressure. And in terms of absolute, this gauge pressure is equal to P absolute minus P atmospheric, and this vacuum pressure is equal to P gauge minus this P atmospheric. So this is all about the different types of pressure. Now I will discuss what is Newton's law of viscosity. Basically, it states that the shear stress on a fluid element layer is directly proportional to the rate of shear strain or velocity gradient. Mathematically, we can write shear stress tau is directly proportional to, according to Newton's law, du over dy, या tau is directly proportional to d theta over dt, where du over dy is the velocity gradient and d theta over dt is the rate of shear strain. So mathematically, we can say that tau is equal to mu du over dy, where mu is the viscosity, या dynamic viscosity. Then what is Newtonian and non-Newtonian fluid? Basically, Newtonian fluids are those fluids which obey Newton's law of viscosity. यानी कि those fluid which follows Newton's law of viscosity is called Newtonian fluid. And what is Newton's law of viscosity? The rate of shear stress is directly proportional to rate of shear strain या velocity gradient. So this type of fluids comes under the category of Newtonian fluid, and examples of these fluids are water, air, gasoline, petrol, diesel, kerosene, mercury. These are Newtonian fluids. Then what is non-Newtonian fluid? The fluid that do not obey Newton's law of viscosity means in this type of fluid, shear stress is not directly proportional to rate of shear strain या velocity gradient. That type of fluid is called non-Newtonian fluids. And the examples of these fluids are toothpaste, blood, milk, paint, ketchup. Comes under the category of non-Newtonian fluids. Further, non-Newtonian fluids are categorized into these 3 types: pseudoplastic fluid, dilatant fluid, and Bingham plastic fluid. So these are the further classification of non-Newtonian fluid. In this graph, in x-axis, this is rate of shear strain या velocity gradient, and in y-axis there is shear stress. So this is those fluids which follow this line is called Newtonian, and those fluids which follow this line is called non-Newtonian fluid. Now I will discuss what is Pascal's law. So basically, according to Pascal's law, pressure applied at any point in a confined incompressible fluid is transmitted undiminished in all directions throughout the fluid according to Pascal's law. The applications of Pascal's law is hydraulic jack या lift, hydraulic brake system, hydraulic press. According to Pascal's law, the pressure is transmitted in all directions throughout the fluid. In last, what is continuity equation? So basically, continuity equation is based on the principle of conservation of mass of a fluid in motion, and it states that the mass flow rate of a fluid remain constant from one cross section to another in a streamline flow. Suppose this is a variable cross section 5, and in this pipe this is cross section 1, this is cross section 2. So according to continuity equation, mass flow rate at section 1 is equal to mass flow rate at section 2. Mass flow rate is also equal to rho 1 A1 V1. It is also equal to rho 2 A2 V2, where rho 1 and rho 2 is the density of fluid at section 1 and 2 respectively, whereas A1 and A2 is the cross section area of pipe at section 1 and 2 respectively, and V1 and V2 is the velocity at section 1 and 2. If density is constant, yani ki rho 1 is equal to rho 2 is equal to rho, then this is cancelled out, and according to continuity equation, A1 V1 is equal to A2 V2. So this is all about continuity. So this is for this lecture.